Welcome back to the third part of the audio white paper of the Itheum project. Don't forget that in the video description you can find the link to their wallpaper. If you came directly to this clip, without seeing the first part and second, you now have a link to that clip on the screen. I recommend you look at that first and then come back here to continue. Let's go. Data coalitions. Independently selling personal data is inefficient and time-consuming. Continuing to curate and monitor the terms and conditions for each sale, as well as to keep track of what data will be used for and by whom, will quickly become overwhelming. Your personal data, both the longitudinal data from your structured programs and highly personal and sensitive data from your vault, is also not very valuable when viewed in isolation, but when your data is grouped into clusters of similar people, it grows significantly in value as the volume and quality increases, e.g. Your health data is worth greater than $1,500 if sold as part of a larger dataset. The grouped data then becomes useful for deep analysis, or to train machine learning models, for example. We believe that this is the future of how data will be sourced on the blockchain to train AI, and for deep analytics. Data coalitions are DAOs, where the creators of the data coalition will bond MYDA to form and run it. The creators are called board members, and they have an incentive to run the coalition in the best interests of its members. Board members have a stake in the game with their bond and therefore will need to always act in the best interest of the members. Board members will also earn a share of the trade, so it's in their best interest to keep their coalition as robust as possible to attract new members, and therefore more data. Itheum envisions a future where the most successful data coalitions will be run by enterprises and SMEs, subject matter experts like legal and regulation experts, commercial data warehouses, academic/research institutes, government departments, etc., and will be the perfect balance between commercialization of data and accountability to end users, data providers. Board members vote to agree on the terms and conditions and the governance, privacy and security of the data trade. The parameters they agree to will be made visible to anyone who wants to join the data coalition. Users, called members, can then align to the coalition who they feel acts in their best interests. You then delegate the ownership of your datasets, data streams, and data NFTs. The coalition will group your data into clusters of similar data and sell the data in bulk to a larger column of buyers. In return, you can earn a steady value return on your data or choose to lock up your returns for the longer-term growth of the coalition's network. Data coalitions also allow for staking of MYDA, where anyone can stake their MYDA with a coalition. You don't have to provide your data to flag their support for the data coalition and to signal that the data within the coalition is good. Crowdsourced data curation. This allows for Itheum to be used by users who want to participate in the personal data economy, but who don't necessarily want to provide their data at that point in time. All parties involved in the data coalition, board members who bond MYDA, members who share data, members who stake MYDA, are all incentivized relative to their role and stake and earn micropayments after each sale is finalized. Itheum's data coalitions are modeled on the credit union philosophy. Decentralized board members. As introduced above, data coalitions are formed and run by a virtual board. They have additional governance responsibility and can mediate/provide conflict resolution, negotiate terms of sale of data with real-world entities and other coalitions, etc. Board members have to bond MYDA into the data coalition to ensure they have a stake in the game, after which they can stand for election and be voted in by other board members. To prevent hard centralization, board members will serve a fixed term. If required by the members, it's not mandatory, and after which they will need to rotate out and be replaced with a new board. Board members earn a share of the sale in data, paid out in MYDA, that is housed within the data coalition. They can also lose MYDA in case they don't represent their members' best interests or conduct an incorrect sale of data that breaks the terms of sale contract and need to revoke it and pay back the buyers and compensate sellers for the damage. Although not mandatory, members will be able to participate in ongoing period votes to express their satisfaction with the board's performance. If satisfaction rates are low for multiple voting points, this will trigger a board rotation clause. Other notable properties of data coalitions. Data coalitions enable collective bargaining power for end users. and will be a viable solution to the problem of centralized enterprise data silos that don't provide any value to the data creator. DAO-based governance and modified proof of authority-based decision-making will be involved in ongoing operations of the data coalition. They will also be delegated custodians of data vaults, and can autonomously trade high-value data from the vaults by attaching it to the other datasets within the data coalition. They will also be able to link with the trusted computation framework and facilitate the privacy-preserving compute-to-data technology handshake, where third parties will be able to run algorithms on the datasets housed within the coalition without having the identity and privacy of the original data creators leaked. They can efficiently facilitate micropayments to all its members in return for data. For example, a data coalition can have 1,000 members who contribute data for bulk sales. After each sale, the 1,000 members will be sent a share of the earnings via micropayments. Traditional banking payment systems are unable to handle these kinds of micropayments due to the overhead of fees and charges, but crypto will be able to facilitate this well. Data coalitions in future will also trade with other coalitions and be connected to autonomous machines via machine-to-machine type interface. E.g., wearables or EVs who join coalitions directly and participate in the data economy. They can allow, if voted by members, for anonymous cohort analysis of data trends via tooling provided via our data collection and analytics toolkit feature. For example, there may be a data coalition set up for the collection of fitness and demographic data where you, as a data creator, can align to and sell your wearable data from Fitbit or Garmin, as well as append specific demographic data from your data vault, e.g., gender, age, ethnicity. To enhance its value, anonymous cohort analysis can then be enabled to visualize the type of data under the control of this data coalition. This adds more appeal to buyers who can preview data with more detail before committing to buying at a premium price. Anonymous cohort analysis via our data collection and analytics toolkit integration. By default, the Itheum Data DEX supports any data uploaded in valid JSON format. But there may be some specific data substandards that will be more appealing to certain types of niche buyers. For example, buyers who are interested in health and genomics data for automated ingestions into their systems will prefer a more globally interoperable standard like FHIR Fast Healthcare Interoperability Resources Standard. Data coalitions will be able to mandate this as a minimum requirement for its members and ensure that the data being contributed is in the FHIR JSON standard. Anyone can start a data coalition, but it will take some effort to progress it into an operational mode and attract new data to come under its control. E.g., if you start a new data coalition, you will need to bring in board members with credibility and who will need to bond MYDA for their term duration. Once you have filled the minimum requirements for the board members, the data coalition then enters operational mode and can begin accepting data and MYDA stakes from regular users, members. But being in operational mode is not sufficient to attract the best quality data. All details about data coalition board members are made public, so you must have some commercial experience in data-related matters to give you credibility. Any slashes or disputes arising from your data coalition's trade activity are also made public. This is very similar to how the delegated proof of stake validator selection process works, where you can stake your tokens after doing some due diligence on the validator's reputation and past performance. So for a data coalition to be successful, it will need to be in an operational mode and have some credible board members whilst maintaining ongoing trade operational credibility. This feature is currently in the detailed design and prototyping stage. Personal data proofs. In the decentralized dApps ecosystem, DeFi, DAOs, or any other application use cases enabled via dApps, smart contracts enable for agreements between parties to execute based on indisputable truths. For example, in a DeFi exchange, a trade transaction between two parties can happen backed by the on-chain state data that confirms that the transaction can indeed proceed, e.g., Party A has the tokens to transfer and Party B is entitled to receive the tokens based on some pre-agreed above condition. So smart contracts enable trustless interaction to happen between multiple counterparties. Traditionally, transactions such as these in finance require a trusted intermediary, such as a bank, to coordinate. But smart contracts do have a key limitation in that the data they have access to on-chain to facilitate such trustless behavior is very limited. We only have data around transaction history and other such on-chain information, e.g., voting outcomes, etc. For more complex trustless applications to migrate to the blockchain, we need richer, real-world data to flow into smart contracts. Chainlink provides this real-world data via their decentralized Oracle networks and enables the technology of hybrid smart contracts. These hybrid smart contracts use real-world Oracle data to make decisions and carry out transactions between parties. Chainlink enables smart contracts to tap into real-world data like exchange price feeds, weather, or sensor data, and allows for the contracts to mediate transactions between multiple parties based on outcomes resulting from smart contract code execution backed by real-world data. But if blockchain technology was to branch out and handle many more mainstream use cases, we will need a wider variety of real-world data to flow into the smart contract world. One type of data, in particular, that is not available today, even via Chainlink Oracle networks, but is crucial for richer blockchain use cases is personal data. As described in the above section titled Types of Direct Sale, the Itheum platform enables data creators to place their personal data for direct peer-to-peer direct sale on-chain. One of the underlying qualities of this type of trade is that a proof of the personal data is stored on-chain. This proof is then used by a buyer to verify that the data's veracity is untampered before the trade happens. These features enabled by the Itheum Data DEX can also be used as a personal data proof by smart contracts to execute specific rules that enable transactions on-chain to happen that are backed by personal data. This revolutionary concept is best explained with an example. Home loan application real-world scenario. Jack wants to buy a house. He heads over to his bank and requests a bank loan. The bank needs to carry out a detailed assessment to make sure Jack is eligible for the loan, i.e., can he make repayments? What is the risk he will default on it? Etc. The bank does a credit check on Jack and finds that his credit history is good. The bank's home loan broker then does an extended personal due diligence assessment. Jack is asked to provide his financial history, income history, and other details about his spending habits, family, dependents, and work history. This information is collected using a detailed bank loan application form the bank has prepared as a standard document. Once Jack fills the form, he needs to attest the form is holding true information via a form of statutory declaration that is legally binding. The bank assesses the details on the form and makes a decision to give Jack the loan. Jack uses the loan and buys a house. Now let's imagine that we want to port this entire scenario to the blockchain and remove as many intermediaries as we can, the bank, the credit history provider, the home loan broker, etc. Home loan application DeFi scenario. Jack wants to buy a house. He visits a DeFi lending dApp that is a DAO, modeled after a real-world credit union, but fully decentralized, that allows for borrowing based on voting-based approval and on-chain evidence of collateral, e.g., other assets that Jack owns in the same DeFi dApp or other dApps. Jack requests a loan and the dApp begins its automated due diligence process. As part of this process, the dApp invokes another DeFi dApp's smart contracts that allows for deep credit history checks, possibly via deep index lookups or via the graph for more advanced lookups. The credit checks come back positive for Jack. The DeFi lending dApp then refers Jack to an application form built and run using Itheum's data collection and analytics toolkit. It includes all the regular questions asked by banks during loan applications that needs to be asked to an applicant directly, e.g., what is your employment history? Your spending habits? Your family details and other financial responsibilities? Basically, all the personal information that is needed to make an informed decision about a borrowing risk but cannot be obtained using blockchain lookups. Jack completes the form and his responses are stored inside the Itheum Data DEX as a data pack. Jack then advertises this data pack on-chain, and the proof of his response is published on-chain and sent to the DeFi lending dApp as a personal data proof and attestation to his responses to the form. The DeFi lending dApp now has all the information it has to take his application to the final DAO voting panel. The members of the DAO have all the attested information and proof to make a decision on the home loan, collateral confirmation, positive credit history, application form due diligence responses, and on-chain proof. The DeFi lending dApp is happy with the application and approves the loan, and Jack receives the money. Itheum provides the complete platform for these kinds of personal data proofs that can be used for on-chain decision-making. Think of Itheum as the next layer of data inflow into the blockchain world. Core blockchains provide transaction data, Chainlink provides real-world event data, and Itheum provides personal data proofs direct from the end user. When used in unison, we can replicate many real-world scenarios using smart contracts and remove redundant intermediaries. Data Vault. You can store highly sensitive personal data in your data vault. For example, details about your gender, race, sexual preference, prior health conditions, financial history, etc. This sensitive data is encrypted using your own encryption keys. No one else can unlock and view it, and stored in IPFS. No one else can destroy it. You can then choose to append data from your vault to the regular data you sell on the data DEX. As this gives the dataset more context, it becomes more valuable to the buyer, and you will earn more MYDA. As the data is encrypted using the user's private key, we need to enable a frictionless UX during trade between buyer and seller, where keys need to change hands with minimum manual involvement between parties. For this purpose, symmetric key pools, decentralized middleware, are used to enforce secure authorization between seller and buyer in real time. Symmetric key pools operate using a modified proof of authority mechanism to enforce the highest security with balanced decentralization. Other notable properties of data vaults. Their design will enable true data sovereignty via a proof of ownership-based design architecture. Detailed technical design of data vaults will be released in our yellow paper, but at a high level, all datasets that include sensitive data will be encrypted with keys that belong solely to the data creator/owner. If a copy of the data is given to a new buyer, decentralized middleware will be used to mediate the handover of the copy to the new owner, with encryption handled behind the scenes to ensure UX is seamless. But in the case of a data NFT, where the actual ownership of a data asset can move from one party to another, the proof of ownership will also be transferred. This process will also be handled by the decentralized middleware service. Data vaults will enable a user to opt out of the system in the event they do not want to share their data anymore, e.g., a requirement in GDPR. This is achieved by the above-mentioned proof of ownership protocol, where the unique decrypting key can be burned, which then effectively makes all decentralized copies of data, e.g., in IPFS or elsewhere, become untethered from the data creator. The data without its decryption key is now effectively just a blob of the scrambled text without any identity or utility attached to it. There are of course challenges to this that we need to solve, e.g., what happens if you sell your data and then change your mind after the sale? Do we allow for a recall of data sale? If so, how can we ensure a user can completely opt out? This feature is currently in the detailed design and prototyping stage. Data streams. You can let buyers subscribe to personal data streams. Unlike the on-off datasets that can also be purchased on the data DEX, data streams will continue to feed data once a subscription is purchased. Streams are a more powerful way for buyers to subscribe to longitudinal datasets that grow over time. For example, health and wellness data like activity, sleep quality, blood pressure, or financial activity like spend habits, etc. When paired with context-rich data from your data vault, streams become a valuable and steady source of passive income for you in exchange for your personal data. This feature is currently in the detailed design and prototyping stage. Trusted computation framework. As personal datasets under the control of data coalitions grow over time, certain end-use cases may require access to highly sensitive, identifiable data. Often these use cases will provide the most payout for data usage, as such they are considered high-value use cases. In such situations, a trusted computation framework can be used to ensure computation is handled off-chain with tamper-proof integrity. The data coalition will coordinate these computation jobs on-chain, with possible coordination assistance of Chainlink's-attested oracles. All personal data traded on the on-chain DEX is never stored on-chain, only hash values are stored to ensure the integrity of traded datasets. But in certain advanced use cases where data coalitions manage the data of multiple users, there will be encrypted personal metadata stored on-chain. There will be cases where this data cannot be put on-chain even when encrypted due to privacy regulations, especially if the blockchain network is spread across multiple geographies. Off-chain execution is, in some cases, the only option for processing this data. Trusted computation framework can be used to localize the computation of the data to ensure the data storage and processing complies with all data sovereignty regulations. The Trusted Computation Framework is tethered to the Regional Decentralization Hub and is our compute-to-data solution for highly sensitive data processing requirements within high regulatory environments. This feature is currently in the research lab stage. See you in the next episode. On the screen, now you have the link to it. Don't forget to like this video if you liked it, it helps us a lot.